Hello, I am Sebastian Tello-Trillo.
And I'm Alex Hollingsworth.
Welcome to The Hidden Curriculum,
a podcast where we talk about all the stuff you didn't learn in graduate school. Hey, everyone. I hope that you had a great week. This week, we're really excited to bring you an episode. But before we get into that, Sebastian, how are you doing today?
I'm doing really well. I had my job market paper finally got accepted. Woo! We did it.
Yeah.
Boys.
5 years later.
5 years later, guys. It's
Yeah.
So, my maybe recommendation tip is going to be about that. And I'll talk about that later.
So I will ignore a banter question for today. We'll just celebrate the glow of your job market paper being accepted.
Did it.
Awesome. Well, our special guest today is Julian Reif. Julian is an assistant professor of finance and economics in the Gies College of Business at the University of Illinois. He's also a senior scholar at the Institute of Government and Public Affairs and a faculty research fellow at the National Bureau of Economic Research. His research focuses on health policy evaluation and the value of health and longevity. Julian received his Ph.D. in economics from the University of Chicago and his B.A. from Vanderbilt. There you go, Sebastian.
Woo,
Julian, how are you doing today?
That's right. All right, great. So this is a good time to transition. So for our listeners of the podcast, what we're going to do now is we're going to go through Julian's guide. He has kind of like a stata coding guide and also an R coding guide, but we're going to focus on stata. And he has a lot of different steps that you can follow, and it's really easy to follow. But what we wanted to do today is to kind of get us started there and maybe ask questions as we go through of the why we're doing this and the where we're doing it. We're obviously not going to go through the whole guide, but we're going to give a nice overview. And we'll have it all as a video as well, so you can do it as we're doing it later on whenever you want to. So this is great for people who just are going to start a new project and maybe want to find a way to start being organized. All right, so for that, I am going to share my screen. So now we're entering that transition part. And here we have this awesome guide. When did you write this guide, by the way?
I think this guide is about 1 year old now. I should also emphasize that I'm updating it over time. So there'll be changes that'll be made to it, later this year and so on. Basically, whenever I update my personal organizational structure, I update it on the guide. I try to keep them synced.
Okay, great. Awesome. So there's a little motivation of why we want to do this. Things like minimize coding errors, automatic creation of tables and figures, integrating stata code with supporting for R analysis, which is great, and produce replication packages, which are obviously really cool and very important. There's also, I think, maybe an assumption that a lot of us use services like Dropbox or maybe Box.net that they can use to be synced across computers. And obviously that makes things a lot easier when you're using different computers or across different co-authors. So the first step is to set up a stata profile. Can you tell us, Julian, what a stata profile is?
Yeah, so the stata profile is essentially just a script that stata automatically runs every time you open it. So when you open up stata, if you have a stata profile set up, it'll tell you running, C addon personal profile.do. And any code that you put into that script will be automatically executed. And so it's very nice for putting automated things that you will want available to you every time you open stata.
Great. And so this is located, if you go, for example, I'm going to go to my PC, C addon personal, and then you'll find it right there. And on Macs, it should be around the same or similar file path, right?
Yes.
Okay, great. So I'm going to open this profile that I already created. And this is what I did. And let me ask Julian if this is maybe what they recommend. So I just set up a global of where in this computer Dropbox is that I call Dropbox. And so in another computer, this will be different. And same thing, I have OneDrive for Microsoft Office, and I do the same thing for that. And then the last thing that I do, and I don't know if I should do this in here or reverse, is to tell it to run this addon that is called stata profile addon, and I'll talk about what that is. So am I doing it right or am I doing it wrong?
Yeah, well, that's how I do it. So
okay, good.
I'll call that right, at least for the purposes of this. But yeah, I think that, essentially the idea is anything that's specific to your computer, you want to put inside of this profile. And a lot of us who are sharing environments across Dropbox, you can put your, a secondary profile on Dropbox that you call from this one And then you only have one profile you have to update each time.
So I just have two quick things. One is just an interjection. If you want to find out where your personal folder is on Stata, you can just type in sysdir, SYSDIR, and it'll tell you all the locations that Stata looks for different things when you open up Stata. And then the second thing is a question. So I've recently started using Stata projects quite a bit, which basically makes it so all of the files within Stata are relative. Now, this doesn't have the ability to run commands. Like, so if I wanted to like set a certain scheme for graphs or something, every time I opened it up, the profile.do is going to be better for that. But do you have any thoughts on like, are projects good? Are they bad? Or are they just like not a part of your workflow yet?
Yeah. So the only thing I like to use that's defined outside of sort of the immediate project environment is just the global that points it to a project folder. I like having everything be self-contained personally. And so essentially the way I design my analysis is that if you were to download, one of my projects or one of my paper, one of the data and code repositories for a paper of mine, I want you to have to, at very most, change only a single line of code. And that's the line that defines where the folder is that you just downloaded to your computer. Right. And so you define where is this folder, and then you just click one script and everything will be reproduced automatically.
So I guess that's what I thought that the project was, is when you opened it, it just tells your computer this is where the folder is.
So well, I guess I'm not exactly sure what you're referring to, but the way the globals work, right, is that they're pointing to the directory that you're in. And so that's what I use to reference which directory you're in.
Okay. So I think it's in newer versions of Stata. There's a new thing where you can like create a project, which is like similar to an R project, that when you open it, it just takes you
there.
It's like
Can
your
you tell
way
me
of
how to
opening
do it
Stata.
here, Alex, maybe? So
if you go to File,
okay,
and then if you go to like New, on yours, I'm not so sure. So on mine, when I go to File, I can go to New and then Project. You have a PC, so it looks like your options are slightly different.
Yeah. Okay. Well, we'll have to figure that one out, because I've been told about this, but I've never seen it of how I can actually do it on a PC.
So on mine, it's basically and it's on the Linux version and Mac. So those are the two that I use.
Okay.
But it has replaced the profile.do for me. But again, profile.do is useful for other reasons because it runs code. But I just wasn't sure if like there were other pros and cons of the project.
Okay. So the reason why I like this setup too is because in any computer that I start, it'll actually tell the Stata where the Dropbox is. And that's really nice because then you don't have to like be setting that over and over. So the next step is to create this data profile I do. So this is, let me go a little bit here back to the guy. So the guy said something about set variable abbreviation offs. What does that do? Because I did not include that on mine.
So in Stata, you can refer to variables in an abbreviated manner if you want. So for example, suppose you have a variable called price in your data set. And instead of saying replace price equals 3, you could say replace PR equals 3. Instead, it would know what you're referring to. All right. So that's convenient if you have long variable names, but it can also cause problems, right?
Yeah.
Where your code runs because you only have one variable named price, but then you add another variable, let's say probability. And now when you say PR, Stata doesn't know which one you're referring to, and it will generate an error.
So it's just a good practice to not use abbreviation, et cetera.
Yeah, I think it's a setting that, in my opinion, should be by default off. I think for historical purposes, going back to very old versions of Stata, it's by default on.
This is great. I didn't know you could turn this off, and that says annoyed me or surprised me before. I'm like, how is this running? And I found something similar.
So the next thing that we're going to do is we're going to create globals for each of your projects. So for example, if your project is called licensing or my project, you call the Dropbox variable with a $sign and then / where the folder is. And so that's what I've done for these different projects. My question here is like, is that the only thing you do here in the Stata profile or you're going to add other stuff?
That's pretty much all I do. Okay. And so again, and this mostly goes back to, my philosophy that I like everything to be self-contained within the project.
Okay.
So, because I do not assume that when a user someone else is running my code, right, that they have a profile set up like I do. right? So suppose I put in, you could, for example, put in some default settings for your graphs, right, in your profile. Some people like to do that.
Right.
The problem is if I'm working on a project with Alex, right, and Alex doesn't have those same settings, when he runs the code, it's going to output the graphs without those settings. So I don't like to have those settings be personal to me. So I basically, the goal for my profile is only to define where the different directories are, so that when I open up, I can run any script from any computer anywhere. But any user could just do that themselves by just defining that one global, which is where is the project located. Right. So it's pretty minimal. So
one thing, for example, I did here, and now I realize why you don't do this is I created this program called Prep, because one of my projects is about prep, and I defined using the Dropbox and the global and a prep global where the kind of like data is, the do files, etc. But then the problem is that somebody will also need to have this in their stata profile in order for this to work. But if I put this somewhere else, then that's a fine way to do it. And do you use like programs to define where your directory stuff are, or how do you do that for your projects?
So I have one global per project. So if I'm working on a project with Alex, for example, let's call it our project. The only thing I will define for that project is the location of our project, where it is inside of the Dropbox file structure. I see.
And so when you're like in do files, writing things, and you want to, let's say, use a data set for that project, you just type the global and kind of like data folder and then the name of the data set.
Yeah. Okay. Yeah. So because one thing to be aware of about globals is that as their name suggests, they're global in scope. So when you define a global, it will be available and it will be referenceable inside of any script that you ever run in stata, right? And so you don't want a lot of these names and variables floating around, because eventually they might conflict with each other. If I had 1,000 of these, right, then maybe all of a sudden one of them is going to interact with something else that somebody else has defined inside of the same project. So I try to keep these fairly minimal because they cannot conflict with any other global in any other project that I have.
Okay, gotcha. And then one issue also that I have, for example, is that in some projects, I'm going to use data or a data set that I clean from another project or something like that. And let's say I'm in a laptop where I'm not able to store a bunch of information. So do you have a way of addressing that, or you just try to keep all the data, as self-contained as possible? Or maybe you don't find like space issues, so you haven't solved that in a while.
Yeah, so I will try, if I have data sets that I plan to reuse, I have a special data folder on one of my data drives. Okay. With, for example, for the vital statistics data, which I've used in several different projects, I have all the raw data on this data drive. Okay. And I can have multiple projects pulling from these raw data sets if I want to.
And that global, you define it here in a stata profile?
Yeah, so I would. So that would be a global. I think I just call it research data or something.
And then another way of handling that same thing, but it's a little more prone to error, is to create like basically shortcuts. So like on a Unix system, you can make a symbolic link. So like I have used the same mortality data and it's pretty big. So I basically keep it on one spot on my computer. And then in any project in my data folder, I create like a symbolic link back to that. So if you look at the actual folder structure, it will look like I've got that mortality data in that same project. I don't need a global for it, but really it's just referencing back. And now when you share with the co-author or do something, you need to be careful to make sure they have the same symbolic link set up. But like it's one way to reduce repeated raw data storage.
Gotcha. And one more thing I will add is what I will also define here are, for example, the locations of confidential data sets.
Oh, nice.
Sometimes if I'm working, so actually, for example, in the paper that I was describing at the beginning of our conversation with Jason, we have confidential data from Add Health. We don't store that data in our main project folder. That's there. It's stored separately on a hard drive off the network. And so we have some code that works with the data and cleans it, and it's referencing a global that's specific to that folder with the confidential data. This way we make sure not to commingle any of the data sets.
I see. Gotcha. So the next part that you have here on your guide is to create a folder structure that behaves well. So tell us a little bit about this folder structure.
So the structure starts with two folders. One is a folder called scripts. As the name suggests, this is where you put all of your scripts, whether they're written in stata, R, or whatever. This essentially is all of the code that you would need to run your entire analysis from beginning to end. Okay. And then the other main input is data. And in here, you would put all of the starting data sets that you begin using in your analysis. So this might be a file you downloaded from the internet, or some Excel files with hand-coded variables in them. And the idea is that the data folder is read-only. You will never write any output from your scripts into that folder. You'll write those into separate folders like results or processed or something. And so you can always at any point delete every other folder in your project folders. You can delete the results folder, you can delete the process folder, and you're left with just scripts and data, and you rerun your analysis from scratch and it will regenerate everything. And
that is like the dream goal, right?
Yeah, exactly. Yeah. So you can, it's a good way to test, if you have intermediate files and you think, well, I don't really need this intermediate file because it was produced, from an original file in the data, then by deleting it and rerunning your analysis, well, first of all, that checks to make sure that's true. And this is a good way to ensure that you're not accidentally using some old intermediate file that maybe has old data in it, and you thought you were using the newer data, but that actually wasn't true because you messed up a path reference somewhere.
Right. And okay, so I hear my kind of setup is I have data and what it would be scripts is 2 files. Do you also have folders like literature or presentations, things that are not necessarily code related, or you keep that also separate?
I have those folders. I store them one level up, which I think if you scroll down in the guide, there might be an example. Yes.
I see. Yeah.
And so this is also done on purpose because this analysis folder the idea is that this eventually will become your replication folder. Okay. And in your replication folder, you don't necessarily want your literature references or your manuscript, et cetera. I mean, you might want those, but you also might not. Also because my replication folder usually ends up being a separate folder for various reasons. For example, I'll have a paper where I have my analysis folder. I've run everything from beginning to end. Now the paper's published. And now the AEA data editor comes along and says, I need you to create a replication folder. Right. It's not an exact copy of my analysis folder because, for example, maybe I have confidential data that I'm not allowed to share, right? So what I do is I just make a copy of analysis folder and then I rearrange things as necessary, usually moving some data sets out. But by having everything be separated like this,
it's easy to manage it, right?
Exactly. And it's all still inside of whatever my project directory is. So.
That makes sense. Okay, let me keep going. Alex, you're good, or you wanted to say something?
No, this is great. And just so you guys are aware, I think that we're doing a good job explaining what's going on the screen, but we're sort of scrolling through this stata guide as we're going on and trying to talk about the high level reasons behind everything. Yeah. So I guess as Sebastian's scrolling to the next one, I have a question about this. Could you just walk through the basic logic of why we should be saving our user add-on programs in both stata and in R? Because I think this was, I had never thought about this. And as soon as I read your guide, I was like, this is obvious. And I now do this in every project, right?
Yeah. Well, I guess I can push it maybe even to a broader question of just what is the reason all of these things were developed was essentially out of frustrations from when I was trying to reproduce papers back in graduate school. So, that was, for me about 10 or even 15 years ago now, right? I would go and I would download code, download data from different papers, and they would never run for lots of different reasons. But one of them is because if you have an add-on program, for example, Reg HDFE, which is a very popular one, if you download this add-on and use it, and you don't include it with your code, then when someone else tries to download your code and run your analysis, they're going to get an error. Right? Because they don't have the program. Now, you might say that's not a big deal. They just need to go and download it, right? SSC install Reg HDFE. But oftentimes these programs are being constantly maintained, right? Reg HDFE is an example. It's being improved over time. And even the best programs have bugs in them, right? And we like to fix those bugs. So the newer version may not actually produce the same results as the older version, right? And if that is in fact the case, when a user downloads your data and code and tries to replicate your results, they'll be unable to do so. And they won't know why, right? Maybe it's because there was a bug in this add-on program. Maybe it's some other error. But the way to ensure that this doesn't happen is to keep a copy of the add-on program, right? You should think of it just like as a piece of your own code. You need to have all of your own code to reproduce your analysis. You also need any other user code that you're using to reproduce your analysis.
And this means, just so everyone's aware, that like you will have maybe different versions, but maybe the same version of Reg HDFE installed in various places in your computer if you have multiple different projects, right? So that like basically Julian's recommending here creating like a stata packages folder and then installing all of your, when you SSC install, having it install into that location, and then also calling just that location, not everywhere on your computer when you use it.
That's right. And the good news here is that add-on programs in Stata are very small in size. So this is not going to use up a lot of room on your computer. One of the challenges when you're working in R is that many of the add-ons are actually quite large in size.
Indeed.
So there are ways to address this issue in R as well, but they're a little bit more involved because it's not always very easy to just keep a copy of, for example, tidyverse, which is hundreds of megabytes in size, and you also need one version for each operating system you're working on. The Stata add-ons are cross-platform by default, so you don't have to worry that, oh, I need to download, a copy for Windows and for Unix. If it works on your Windows computer, it will run also on Unix and Mac.
And what you just mentioned about R is very true. So I work on R, I use R, and I work across different operating systems and different versions of R. And there's this wonderful package called Renv, which is RENV, which basically automates this version control issue for you of the packages. But it is absolutely the case that I have like probably 10 gigabytes worth of like tidyverse on my computer when I don't need that many.
So you keep them under scripts, right?
Yes. So the scripts folder keeps anything which is code related. And so what I recommend in the guide is essentially to have a subfolder in your scripts folder called, I call it programs.
Yeah.
No, sorry, I think it's packages for the user add-ons. And basically inside of packages will be a copy of every add-on that you've downloaded or that you use as part of your analysis.
So I want to go and do that because I think that's important to do. So I'm going to call it programs for now. So let's say I started my do file, sys use auto, and let's say I want to use step. So why would I be typing?
Sorry, say you want to use what?
Oh, step, or I don't know.
Oh, yeah. So there should be example code in the guide. The file is called install stata packages _ install. Yeah, I see it there at the bottom of your screen. So if you click on that.
Oh, got it. Okay.
This shows you the code for just installing an arbitrary set of packages, essentially. So I'm installing, I think RegSave and a couple other ones. You can just replace those names with other packages.
Okay, got it.
But for SSC, you're going to have to use the one below.
But why say for each P? Why do I need a loop?
If you have many packages.
This is only because I'm installing multiple packages. So what I'm showing here is two different ways to install them. So you can install from GitHub if you like, or you can install from SSC. So the programs you're seeing there, those are linked to my GitHub repository. So you can only install packages that I've written. But if you look at the bottom half of that of this script, you'll see also a way to automate installation from things that are on SSC. So I think for the program that you mentioned, SStep, you would want to use the SSC installation.
And the key thing here, just so we're aware for those of you that are listening, is there's this, you can set the do path file, which is basically, you can tell Stata, hey, all the do files and all the do files that I'm going to use are going to be in this particular location. And so that's the key thing here to be doing. And then you can do that on servers as well. And this is a nice way if you let's say you have access to a server that has really good computational power, but you don't have access to the internet on the server, save through like the ability just to like upload files. You can like download the files onto your own computer. And then when you upload your code, you can also upload these user written packages and things.
Okay, so I'm doing it here where I set up my global for my project. And then I need this. So this is just creating a folder on scripts called libraries and then libraries data. Okay, so that's that, doing that. So let's run that. And libraries, stata. Wow, amazing. And then this is where it's setting like all the new addos, put them in this folder essentially.
That's right.
And now let's see if Julian is right. We're gonna wait. No, I need to copy and paste the. Oh, is this right?
Yeah, I think you just run that for loop.
Okay, but this is to your website, right?
Yes. So what this will do is this will install the most recent version of my packages, which I keep up to date on GitHub.
Okay.
My packages are also available on SSC. And so below on that, on this example in the guide, I also provide instructions for how you would install from SSC if you prefer. You can use either one of these.
I see.
For GitHub, of course, you're going to need to have it linked to the specific GitHub site for that command.
Okay. Let me try this one. And why are we using here this local? What is it doing?
So this is just basically telling you where this particular command is stored. So the way SSC stores them is alphabetical according to the first letter of the command's name.
Okay.
So
I'm going to run it.
That's what's coming from that.
Let's see if he's right. Ladies and gentlemen.
It turns out the man who wrote the stata coding guide provided correct stata code for doing this. This worked.
Wow. Let's do a round of applause for this thing working so nicely. Okay. I have to be honest with you guys. I've been like scared of doing this because I didn't actually understand what this was like. I don't know if I need this or not. So I'm really happy that now it's done. So now when you're starting your project, this is what can go first. And here, as you're, I guess, installing or know that you need to install user like define programs or whatever, you just add this to this list essentially, right? And you can even create a global of commands, I guess, and then just put them there.
Yeah, exactly. You can just add them on as you want here. If you want to install a newer version of it, if you hear that the author uploaded or updated the version of their command, you just rerun this file, and it'll update the versions that you're using. And one important thing I'll note here is that this is not a file. This is not a script that you will include in your replication package.
Oh, okay.
Because once your paper is published, you want to lock down the version of these programs. You don't want them to be updated anymore. That's the whole point. So when you're done, you will then get rid of this file, and because you want users to only use the ones.
I see, and you just put those programs in that library stata.
Exactly. Yeah, they're going to be there, and the users can use that, and they'll basically always be able to replicate your results. Hopefully, even 20 years from now. One of the things that's very nice about Stata is you can run code from Stata version 1.0, right, from the 80s, and it will still generate the same results on your computer running, Stata version 16 today. There's not a lot of languages that maintain backwards compatibility like that over decades.
Right. That makes sense.
So if you want people to still be working with your results many years from now, I think Stata is a good choice.
Okay. Great. So after that, it goes into code about how to output tables, which obviously you guys can see there. I think maybe the last thing that I'll talk about really quickly here is the stata coding tips, and I'll share it so you both see it. So really quickly, do you want to maybe go through each, not enough through each one of them, but highlight any of these that you think are important, maybe you get a lot of questions about?
Well, I think the one I will echo as being perhaps the most important is never use a hard-coded path. So this is probably something that all of us have encountered when trying to reproduce another paper. You download the code and it breaks because it's referencing a folder called user/Jane Doe, and then that's not you don't have that folder, of course. Right? The way to get around this is to make use of these globals, right? So this way, again, you only have to change one line of code, and everything else will just be in reference or in relation to that particular global, and you don't have to worry about running into errors.
Great. Awesome. Thank you.
All right. So I want to ask a bit about the motivation, about why so much, like, this is a costly effort to do this, right? This isn't something simple. You could easily have produced a number and then written a paper and then just been like, oh, the number is 2. So I want to know from a couple different points of view, what are the personal benefits of engaging in a costly sort of procedure of maintaining a clean house like this? But also, what are some of the professional and sort of larger benefits for science of doing something like this? And do you think that those benefits, perhaps you do because you made this coding guide, but why do you think those benefits outweigh the costs?
Well, I could talk a little bit about sort of my general philosophical or sort of perspective on this. I mean, this goes back to graduate school when I was trying to replicate papers. It was a very frustrating experience. Oftentimes the code would not run, or would have errors, or just not make sense. And imagine if you were reading a great theory paper that had elegant theorems, and then when you went to go look at the proofs, everything was messy and incomplete.
Just a piece of paper.
To the reader.
Yeah. Right. Yeah. Right. It would probably make you rethink a little bit about the validity of the original paper. Right. And so, I mean, I don't want to push this analogy too far, but I do think that, the code underlying a paper is a lot like a proof. Right. Many people don't want to read it. Right. And you may not need to read it. Sometimes even the reviewer may not need to look at your code to feel confident about the result. Right. Same thing about the proof for a theorem. Right. But it's an important part of the paper. Right. And, even with theory, history is replete with examples of when there were errors in theory papers. Right. Sometimes these errors matter. Sometimes they don't. But we obviously want to avoid them. And, so my motivation for putting all this together was, first and foremost, to minimize mistakes in our analyses. Right. Now, a lot of times these mistakes end up not being consequential, but sometimes they are. All right. In any case, I think we can all agree that, we want to get the right answer. Right. And so having something that's organized makes it more likely that we're going to have the right answer. So I think that's probably the first and most important motivation for having a setup like this. I think, there are some other benefits as well, in addition to, having the right answer, which is itself a good benefit. I think it also makes it a lot easier to collaborate with multiple co-authors who may also these days be using different languages, right? You need to have some sort of folder structure that's consistent and can be used across different languages. And I designed this structure to work very well in that kind of environment.
Got to be bilingual.
Yeah, exactly. And it's also something that the more you use, the easier it then becomes for the second and third projects, right? To have something standardized, right? Then the next time you work on it, you already know, okay, I don't have to explain that it's only read-only data sets that goes into the data folder. We did that on our previous project, right? And then, even beyond that, it also makes it easier to share your results and your code and your work with others, right? And that has lots of benefits. So it has good benefits for our profession, right? So it's a social benefit because we get to build on other people's work, right? So if Sebastian has already put together a wonderful data set of, some particular set of legal laws, let's say, right? Well, I don't want to have to redo all of his work, but if I can just download his data and I have his code that rebuilds it from scratch so I can check it if I need to, or maybe make a tiny modification, that's a huge benefit to me. It's also going to be a benefit to Sebastian because I will hopefully cite his work for this. But also beyond that, this is becoming a formal requirement for publication in our profession. I think that will continue to be the case, right? So even if you don't think this stuff is a good idea, if you want to publish in any of the AEA journals these days, you have to go through the AEA data editing process, which, by the way, I've designed the setup to be completely compliant with that, right? So if you follow this setup, it's going to be very easy to get through the AEA data editing process. And so this is obviously all this is a work in progress, but this kind of stuff where you need a push button analysis, I think is going to become a requirement for most of our published papers going forward.
And I'll just say, like, personally, so I started, I love the idea of this push button replicability thing. And I adopted a couple of the things you mentioned, like the stata packages and things, as soon as I saw them in your recommendations. And I recently had to go through the AEA data editing thing. It was a fairly a breeze, relative to I think how it could have been. But also I had some reviewer comments that I needed to deal with. And it was pretty easy to incorporate, like they were hard and I needed to think about them, but like it was pretty easy to incorporate the analyses into my existing structure and click run. I didn't have to rebuild things. Like it was kind of clean. It was clear where it was going. So like just for my own,
that's awesome.
Future you will benefit from previous you
so much
organization.
Yes, that is the hope.
Have you find, just one last question before we outro, have you find much resistance with like co-authors on this kind of setup, or is it that you work with co-authors that are already buying all this stuff? So selection. Yeah.
On the contrary, I've benefited a lot and actually have adapted my setup to suggestions from my co-authors. I've been very fortunate that all my co-authors are all great, and they're all very good coders, and so they will make suggestions sometimes. So hey, shouldn't you reorganize it more like this, or what about doing X or Y to improve the analysis? So this is something I continue to update. And it will continue to improve over time, especially some of the integration with R, for example, in the guide that's still relatively new. R itself is also changing over time. Mm-hmm. So this is something that my co-authors have liked and actually have helped improve quite a bit.
Great. Thank you. Thank you so much for those insights. Every week, we like to ask our guests for our recommendation of the week. This can be anything: a podcast, a command, an app, a song, a quote, a book, our kitchen recipe, anything that improves your life in a small way. Julian, what is your recommendation of the week?
So I recall Alex saying on an earlier podcast that he found that exercise provides him with a lot of physical and mental health benefits. Oh, okay. So I will first say that I'm the same way. Exercise and sleep are very essential for my personal productivity and well-being. And one thing I'll note is I've discovered that exercise is way easier when you have a good podcast to listen to. And so I can make a couple recommendations there. So of course, it's a hidden curriculum that goes without saying. But I have two podcasts that I like to listen to a lot, are Conversations with Tyler and Mindscape. And so Conversations with Tyler is hosted by Tyler Cowen, who's an economist. Most of you are probably familiar with him. He interviews not just economists, but also writers, philosophers, chefs, a variety of different academics. Mindscape is hosted by Sean Carroll, who's a theoretical physicist. So he focuses mostly on scientists, although he ventures also in a couple other areas as well. And what I like about these podcasts is they're very interesting. First of all, I always learn a lot listening to them. They're a lot of fun to listen to, but also they really are nice examples of academics who are able to communicate, complicated but important concepts to the public in a very intelligible manner. And I think that's something that many of us, certainly myself, could always do better at. And I think they provide just a wonderful example of that kind of communication.
Awesome. That's great.
That's great. Yeah. The host of Mindscape, Sean Carroll, I'm like halfway through his audiobook, Something Deeply Hidden. And
that's his newest one. Yes.
I don't know if it's right because it's about quantum physics and quantum mechanics, but he certainly makes me think I understand what he's saying as he goes through. So
that's so funny.
Yeah, he's a big proponent of the many worlds interpretation of quantum mechanics. He makes a good case for it, although I'm obviously not.
So like the MCU, right? There's different timelines. I don't know. Okay, whatever. Alex, what is your recommendation of the week?
So this is kind of similar to one I gave before about using like email templates for stuff, but this is one like I only have like 2 email templates. And since this is an episode about coding, I have a lot of like coding snippets and templates that I use. So like, I guess this is sort of like just use something like Julian's guide. But I actually use Sublime Tech a lot to like write LaTeX and to do other things. And I use a lot of coding snippets there. So like I have like a blank document that when I use like a keyboard stroke, it will like pop up with like a LaTeX document that's sort of got like the preamble of a title page and like all this other stuff ready to go. If you just like sort of type like I and then tab, it'll like start like create like the itemized list framework in LaTeX. And I found this kind of stuff like just invaluable to reducing the cost for me writing because I don't like writing that much. So anything I can do to reduce that cost is good.
That's awesome.
Yeah. What about you, Sebastian? Oh, sorry.
Yeah, my recommendation of the week is, and this is in line, maybe this is similar to what you're saying, Alex, but on Windows, I don't know if this exists on Mac, there is a program called Auto Hotkey program. And you can do this in different ways, but I think that Auto Hotkey is very like foolproof. And the idea is that you can create a script where you put a shortcut. So for example, -S, and then something else appears. So when I do -Zoom, then the link for my Zoom room appears. Or when I do -30 minutes, the link for my 30-minute calendar meetings appears. And it's been like a really, I think, like awesome lifesaver. And like, it's really easy. And people are like, okay, where are we going to, let's jump into a Zoom. So I just do -Zoom and immediately the link appears and we keep going. And I do that obviously on my phone because you have text replacement on your phone. And I do it in my computers. So it works out really nicely. So check out Auto Hotkey if you're a Windows user.
That's
maybe
cool.
There's something for Macs like that or no?
Hey, Keyboard Maestro, but I think you have to like pay monthly for that. So I don't.
Oh, Auto Hotkey is free.
Yeah, there you go. Yeah.
Great. Thank you so much for being here with us today. If people want to find out more about you and your work, where should they go?
They can go to my website, which is www.julianreif.com.
Great. Well, that's all that we have for you folks today. Make sure you subscribe and leave a review and tell your friends about our podcast. Thank you for tuning in. Bye.
Thanks.